Okay, where TIR is used? TIR is used in optical fiber. Okay, optical fiber cable. Optical fiber cable for data transmission. Optical fiber cable for data transmission without wastage of energy. And secondly, TIR, due to TIR means diamond is it is sparkle. The diamond sparkle because of the TIR. TIR because the refractive index of diamond is very high, and that is 2.42. Note it down. Done. Done, Abir?
Yes, sir, done.
And hi.
Yes.
Let's move further. Now today we're going to discuss the image formation by plane mirror. Okay. Sorry, image formation by lenses. Spherical lenses. Okay. So there are the two types of lenses that we're going to study today. One is the concave lens. This is the convex lens. Convex lens. Why it is convex lens? Because you see that this edge is curved. Okay, if you are having the object like this, and you have like convex mirror. So okay, so both are having this type of edge in front of the object. So that's why it is considered to be a convex lens. Okay, and if I'm having this lens, so it will be considered as okay. You see that this is the curved edge from inside, so like the concave mirror. So this is the concave mirror, concave lens. Okay, concave lens. You understood? Understood? Abir and Amma,
Yes, sir.
both. Okay, let's start further.
Yes.
Now, like we have the sign conventions. So here we are going to tell you the science convention also that while solving the problems. Okay. So first of all, let's take the image formations. Okay. First of all, let's take the image formation. By image formation by convex mirror, convex lens. Okay, so if I'm having this convex lens, okay, so there must be an optical center. In the mirror, we have optical center. So in the lens, we have optical center, and in the mirror, we have pole. Okay, this is optical center. That is going to be the center of this one. Okay, and here we this focus. Okay, F1, and this is R1, and this is F2, F2. Focal length for this week. Okay, let I'm discussing F2 and R2. R2. Okay, now the other cases, if I am having, if an object is placed beyond R, so this is similar to this that of concave mirror, image formed by concave mirror. So keeping in mind, both I'm going to explain you and devise you here that if an object in concave mirror, this is focus, this is radius of curvature. If the object is placed beyond R, then its image is going to form between R and F. Between R and F, here the image is formed. Similarly, in the convex mirror, it is the concave mirror, it is concave mirror and convex lens show same types of mirror image formations. Okay, if I'm placing this one as beyond R, and if I'm just placing it a parallel line towards it, then if the line is parallel, if the line is parallel, then it will be passing through focus. And if the line is okay, this is the first line, and you can check if the line is passing through focus, or you can pass through the optical center. Okay, when a ray passes from the optical center, then it goes without bending. Okay, it goes straight. So if the line is passing from the optical center, so this is not an accurate measurement. Okay, this is not an accurate measurement. Okay, so that's why I'm just putting it here. R2. So the image will be formed. If you take the equal distance, means this distance is equal to this distance and is equals to this distance. If it is equal, then from here to here and from here to here. So if it is equal, all the distances are equal. So the image will be formed between F2 and 2F2. Okay, got it? F2 and 2F2 are between F and R. Okay, got it? Understood? When the object is placed beyond R, the image will be found between R and F. Okay.
Yes, sir.
Okay. Now you are very much familiar that this one is the right hand side. Sorry, left hand side. So here is U, object distance. Okay, and it will be considered as positive or negative? U.
Negative.
Yes, it will be considered as negative because it comes on the negative axis. Okay, so this will be negative. And similarly, this is the image distance from here to here. This is the image distance. Okay, and it will be considered to be as positive. The value of V will be positive. Got it? Got it? Because this distance is considered to be as positive. Now, moving to the next point is the height of object. That is HO. Here it is considered to be as positive. And here the height of the image. Height of the image will be considered to be as negative. Okay, because it is downward. You understood?
Yes, sir.
Now, if you consider this one as a this is a convex mirror, and from the convex mirror, from the for the object this one, both the convex mirror, either it is a convex mirror or the convex lens. Okay, both are going to have positive focal length. Okay, convex mirror and convex mirror and convex lens both are going to have the positive focal length. So we'll discuss while we will be solving the numerical. So is it done? Can I move forward? Please make this one. Please make this diagram. Copy.
Done, sir.
Done. Okay, next. Amar, you done? Amar.
No, sir. 1 second.
Okay, do it. When you done, take that. Okay.
Done, sir.
Moving to the next part is that I'm having this another another. This one is F1. This one is which will become here to F1 and this will be R1. Okay, this should be F2, this should be R2. So if I'm having an object that is placed here between R and F, so in the previous one, you know very well that the similar case is that is similar that if the object is placed beyond R, the image will be formed between R and F. And you know the property. The property was that is it will be diminished image. Here it is also diminished image will be formed. Okay, the image will be diminished, real, and inverted. Okay, inverted. Will you keep it in mind? So the similar case. That's the instrument. Now, if I'm having this concave mirror and this one is F and this one is R, if I'm having the object here, so where the image is going to form? Tell me. Where the image is going to form?
Beyond R.
It will be beyond R. So simply, if you have this beyond R. Okay, so similarly, if you are having an object and it is enlarged, you see that this height is small and this is the height, this height increases. So this will be enlarged. Similarly, if you have an object, if it is passing through this, so it will be passing through focus. The next one is it will be passing through optical center. Okay, I'm not able to make the straight line with this one because this is a pen only. So you need to make it properly with exactly. So if it is passing, you need to keep in mind that both the arc or both the rays should pass with the top of the object. Should pass with the top of the object. You cannot make like this. The object is here. Okay, or if you cannot make like this, means if the object is placed like here, the ray is passing above the object, or it is passing between the object. No, you have to pass both the rays from the top of the object. One is parallel. If it is parallel, then it will pass through focus. Other ray pass it through optical center. Then it will be where they intersect to each other, the image will be formed. So here you can see that the image is formed. Okay, got it? And it is object between R and F. Image will be beyond R, comma enlarge, and what? Enlarge and real inverted. Real inverted. Got it? Got it? You understood?
Yes, sir.
Okay, it is a real image. It is a real image for an enlarged image. So tell me the value of magnification will be +1 or less than 1? More than 1 or more than 1? It will be greater than 1, equal to 1 or less than 1. The value of magnification.
More than 1.
Yes, for enlarged image. For enlarged image, magnification is greater than 1. Is greater than 1 and magnification is negative for real images. Okay, keep in mind. Got it? Have you copied this one?
Yes, sir.
The next important case,
No, sir,
object
one
is
second.
done.
Sir, one
Still
second.
doing?
No, sir. No,
Still
sir. I
writing?
just yes.
Down. Done? Amma, done?
Yes.
Now moving to the next type of image formation is this is focus, this is radius of curvature, this is focus, and this is the radius of curvature. F1, R1, F2, R2. Okay, this distance I have kept it more and this I have kept it wrong. This is incorrect. Okay, so I have to make the distance equal. Distance is no, this is distance equals. This one is F R2. Okay, now what we need to do here is next is the only case where the object is placed between optical center, like we are having in the concave mirror. Then the object is placed here, okay, between pole and focus. So similarly, if the object is placed between pole and focus, what is going to happen? Tell me. Tell me.
Enlarged virtual image.
Large virtual image will be formed. So this one is, and the one is this. Okay, we will see that these two are not going to meet, not going to meet. So what is going to happen? They will meet somewhere at back side. Okay, so this is the virtual image. This is the virtual image, and at the same side, of the object. Okay, so convex lens form virtual image at the same side of the object, but here you see that in the concave mirror, you will find that the image is formed behind the mirror. Virtual image is formed behind the mirror. Real image is formed on the same side. In the mirror, the real image is formed in the same side, but in the lens, the real image is formed at the opposite side, like here. Okay, but virtual image is formed at the same side of the object. If the object is placed this way, the image, virtual image will be formed this side. Okay. Now you see here, they are not going to meet together, so they are going to meet somewhere. Got it? Are you understood?
Yes, sir.
Understood? Moving to the next point. Done. This one copied. So here, object
Yes, sir.
is placed beyond. Sorry, between is placed between R and between optical center and F focus. Image will be found virtual and erect. Erect means upright. Erect image will be. Now you understood?
Yes, sir.
Should I move forward? Am I also done?
No, sir. 1 second. Done, sir.
So let's move further. Now the other two cases are when the object is placed exactly at R. If the object is placed, that I'm just going to make it. Let's just imagine here is the lens. If it is R, okay, so object is placed at R, the image will be formed at R. Okay, and of same size. Okay, got it? In the next case is if the object is placed at focus. If the object is placed at exactly at focus, then the image F1, R1, F2, R2, the image will be formed somewhere at infinity. At infinity. Okay, got it? So the real
Yes,
image
sir.
here, real image will be formed of -1 magnification, -1 indicating real image, 1 magnification means same size. Okay, for this case I'm writing. Okay, got it? Note it down. So this is the same case. The object is placed at R. The image will be formed at R of same size. Okay, got it? You understood?
Yes,
Amar
sir.
understood? Amar, you understood?
Yes, sir.
So let's move to the other cases. Now coming to the lens formula, like we have the comparison here. This is the mirror formula. mirror formula, and here it is lens formula. Okay. If I'm having this for mirror formula, we have 1 by f is equals to 1 by v plus 1 by u. And here we have 1 by f is equals to 1 by v minus 1 by u. Here in the magnification, we have minus v by u. Here in the magnification, we have plus v by u. V and u, you are very much familiar that v is image distance, image distance. U is object distance. Okay. Got it? You understood?
Yes, sir.
Okay. And this is the main difference. We have formula f is equals to mu upon m minus 1 for mirror. We have the formula fu is equals to mu upon 1 minus m for lens. 1 minus m. If we have magnification and u is given to us. Okay. And we have f is equals to v upon 1 minus m for both mirror and lens. This is for both mirror and lens. Okay, we have to write this one. While solving the numerical, you need to. Okay, so here in the mirror, we have m minus 1 for when we have u and the relation of m, u, and f. Okay, and for the lens, we have m, u upon 1 minus 1 minus. Okay, and for v, the relation between v, f, and m, here the relation is m, v, sorry, m, u, and f. Magnification, object distance, and focal length. Here is the relation of focal length, image distance, and magnification. Got it? So note it down. Are you done? Please that me.
Done, sir.
Ma done?
Yes, sir.
Okay, now moving further, you need to keep in mind that both concave mirror, this one, and concave lens, this one, have negative focal length. Similarly, both convex mirror, this one, and convex lens, this one, have positive focal length. Go down.
Noted, sir.
Okay. So let's move further. We have a question here. An object of height 2 centimeter. Note the question first. Please note the question. An object of 2 centimeter is placed at a distance of 8 centimeter from a convex lens of focal length 10 centimeter. Calculate a position of image, the size of the image, state the characteristics of the image. Done? Written?
Yes, sir, done.
So you see that an object is of height 2 centimeter. The height is 2 centimeter. So with sign convention, you have to write each and every. The object height is always taken as positive, so you have to write it 2 plus 2 centimeter because object is always placed this side and this is measured with the positive y-axis. Positive y-axis. So display the distance of 8 centimeter. Distance, object distance is always taken as negative because this distance is always measured as negative. Okay, so that is minus of 8 centimeter from a convex lens. Convex lens of focal length. Here the focal length. If it is convex lens, I have to taught you that the convex lens is going to have plus focal length. Okay, means it does not have the negative focal length. So we have to write here plus 10 centimeter. Calculate the position of the image. V is being asked. Okay, and the size of the image and the height of image is also being asked. Okay, state the characteristic of the image also. So can you guess that what is the approximate length of the means height of the object? Will it be greater than 2 centimeter or smaller than 2 centimeter?
Sir, greater
Greater than 2 centimeter.
2 centimeters.
Why? Can you guess the position of the object, where the object is placed between R and F, beyond R and F, or between pole and optical center? Where it is? Can you guess the position? It is a convex lens. You see
It is
here,
between optic center and focal length. So the
Yes.
image will be enlarged.
will be enlarged. Okay, let's check. So actually, this is the this length. You see that it is positive sign, but considering that this is the focal length is 10 centimeter, just assume that this is 10 centimeter because this distance is also 10 centimeter. Okay, this has two focal length. So this is 10 centimeter and object is placed at here. So it is means it is present between pole and optical center. So the image will be found beyond.
Beyond,
No,
between
not
R
beyond.
and F.
No, it is not. It will be found on the same side as the object is. It is not that it will be found beyond R, between R and F. No, it is not necessary. Okay, it can form anywhere, but you need to keep in mind it will form just
Same size.
same side of the of the lens. Okay, same side
Yes,
of
sir.
the lens. So it will be virtual image. First of all, it is being asked characteristics. So it will be virtual image, virtual, erect, upright means सीधी होगी, and the virtual, erect, and it would be virtual, erect, enlarge. So let's take the where the image will be found. So by solving and by putting the formula 1 upon f is equals to 1 upon b plus minus 1 upon u minus 1 upon u. Okay, first make the formula here because u is being asked v. So make the formula of 1 by v. So this 1 by v will be equals to 1 by f plus 1 by u. This will goes to that side. This v will remain this side, and I just write it by interexchanging it. Okay, got it? That 1 by
Yes,
v.
sir.
Now, Amar, you understood? Are you getting my point? What I'm saying? Achha, Amar is not here. Okay. So if I'm writing here 1 by v, so if I'm writing here 1 by v is equals to what is 1 by f? 1 by 10. 1 by 10 plus plus you have to write it with sign convention. Okay, you have to write it with proper sign convention. Focal length is positive because it is convex lens, so I write here positive. And since this is a positive sign, so I write here positive sign. But here you see that u is always taken as negative, so this is minus 8 with sign. Okay. Now you take the LCM of 10 and 8, and that is 40. So take the LCM as 40. So you multiplied it by 5 to make 40. So here you have to make it 5. You have to multiply it by 4, so you have to make it this way. 4. Okay. And since this is a negative sign, so I'm just replacing this negative sign with here. Okay. So the denominator 1 by 40 minus 1 by 40 by 5. Okay, when you multiply, you will get 1 by 40. And this one, when you multiply, you will get 5. So I'm just writing this 5 by minus 40 as minus 5 by 40. Okay. So I'm just writing minus 5. 1 by v. So 1 by v is equals to 1 minus 1 by 40. And again, when you reciprocal it, you will get v is equals to
Minus 40.
minus 40. Okay. So this will be minus 40 centimeter. So minus sign, what is minus sign indicating? That the image will be found on the same side
Right.
as object before, on the left hand side. Okay.
Left hand side.
Got it? And it will be virtual and erect. Okay, so most of the students in solving this question, so first of all, what you need to write here is that you need to keep in mind that you have to write the each and everything before solving the numerical or before putting it into the formula. You have to first write each and everything that is given in the question with their symbols, with their signs. Okay. If it is positive, then write positive 10. If it is negative, then it will write negative 10. Okay, got it?
Yes, sir.
So, Amar, you left the class. Do you understood this question? You got this question?
Yes, sir.
You
My
can-
laptop
yeah.
got stuck, so I had to restart the laptop.
Okay, now you understood, or should I explain you one more time?
Saturday, can you explain one more time?
Okay. So here we have a question. Have you noted this question?
No, so once again.
I have not noted this question. So we have this question that you write it later. First, you listen to it. An object of height 2 centimeter is placed at a distance of 8 centimeter from a concave convex lens. So 2 centimeter is the height of the object. So whenever we are having the height of the object, so it is always taken as positive. Height of the object is always taken as positive because we write this length is positive. Okay? This height is positive because it is measured in positive axis. And here you have this focal length that is of 10 centimeter. It is given of convex lens. So convex lens, you can say that this is convex. X is last at the last. So tilt it a little bit. Please tilt it a little bit and it will give you a positive sign. Okay. So keep in mind always that a convex lens, either it is a convex lens or either it is a convex mirror, both are going to have the positive focal length. So I write here positive 10 because it is positive convex lens. And U is always taken as negative, irrespective whether it is a lens or a mirror. U is always taken as negative. So if it is 8 centimeter, so right here, place in at a distance of 8 centimeter means object is placed at a distance of 8 centimeter from the lens. So we write it minus 8. And then you need to find out the value of V and I. So you need to keep in mind here that the focal length is 10 and the object is placed at 8. So what does this indicate? This indicate that this length is 10. This length is 10 and the object is placed at 8. So it means that it is placed nearer or closer to uh, means uh, means it is between pole and focus and optical center and focus. Because focal length is 10 and object is placed only by 8. So 1, 2, 3, 4, 8. Okay. So here it is placed. Now moving further, we just put the each and everything in the formula. That is 1 by F. That is the mirror formula. 1 by F is equals to 1 by V minus 1 by U. And I just write it. I just take it to this side. Like if I'm just writing, if I keep it here and just bring it to this side, it will become plus. So the value of 1 by V will become 1 by F plus 1 by U. Now just put the value of each and everything here. I just put the value 1 by V. I need to calculate the image distance, which is image distance. I need to calculate 1 by F is what is 1 by F is 10. So 1 F is 10. So we write here 10 because it is positive. So I don't fine. And plus then 1 by U. U is negative in the question. Right, nice. And I simply take the LCM of 8, 10 and 8. That is 40. So for making it 40, I multiplied 4, then I multiplied this one with 4, but this one 4. For making this 40, I multiplied it by 8, so this one also by 8. And thus it become 40. Since this is the minus sign, it will become 4 minus 5. Okay. And it becomes remember to 40. So this I just solve it, so you will get the answer. Okay. Please note it down. Have you copied? Mark?
Yes, sir. Yes.
So let's move further. Tell me, no, the convex lens form. This is a big question. A convex lens form real image 4 times magnified. Okay, 4 times magnified. Calculate real image 4 times magnified. Here it is. There was such question. Let it repeat because it means this is a question that might be such like that I have written here previous in the previous classes. So it might be asked that what is the focal length and what is the object distance. Okay. So I'm just giving you the question. Just please note it down. A convex lens form four times.
Sir, is magnification for mirrors and lens the same?
Yeah, it is same with sign also. If the real image it is, there will be negative sign. Convex lens and form 4 times real magnified image of an object placed placed Place in front. Place at 6 centimeter in front of it. Place at 6 centimeter in front of it. In front of it. Find the focal length and image distance. So here you have f is equals to, because it is a convex lens, so f you need to find out. Okay, magnified, 4 times magnified, but it is real image. So magnification is, if it is real, it is -4, and object distance is always considered to be as -6. So you have to use the formula f is equals to mu upon, since it is length, you have to write here 1 minus m. Now keep each and everything with sign and get the answer. What should be the value of it?
Sir, F is positive plus 4.8.
X is 4.8, f is 4.8.
Yes, plus 4.8.
Okay. Done, you done? Yes. Amar, done you?
Yes.
What you have to calculate f. F is what do you write here? M. The value of m is what you will write?
-4.
Amar, you are not replying to me. This will be -4, and the value of u will be
-6.
-6. -6 upon. That is not working properly. 1 minus
Minus of 4.
So you will get minus of plus of 24. And this will be minus plus. This will be plus of 5. So you get plus. This will 1 plus 5. You will get 5. And you write, you will get 4.8. So if the focal length is positive, it is indicating that the positive 48 means that we are right. Okay, and it is focal length is, since it is the real image, so you can consider this that it should be between, if it is enlarged, then it should be between R and F. So if F is 4.8, then R should be 9.6, and you can check that 6 is between these two, 4.8 and 9.6. So it is placed between R and F. Okay, got it?
Yes, sir.
Next question. A similar case is for the image formed by convex mirror. Sorry, concave mirror. Image formed by concave. This is concave mirror. Sorry, concave lens. So you know, concave lens mirror is this one. It generally form real images. It also form virtual, but generally form real images. Okay. Here, but here you see that this is a concave lens. It is showing the property of that of convex mirror. Okay. So if it is having focal length, if it is having radius of curvature, Similar difference having focal length f1. This one is radius of curvature. So this is the concave lens. So when you place an object,
Hello, sir. Can you hear me?
yeah, I can hear you. Did you did that question? The previous question? Did that previous
Hello, sir.
question? Yes, I'm asking. Have you done this question? I can hear you. I can hear you. Like,
Yes, sir, but your voice is getting stuck for me. So 1 second. Okay. Yes, sir. Yes.
so let's move further. You have to just put the value. Now I'm just teaching you the what I'm going to what I'm teaching right now is image formed by concave mirror. So concave mirror only we have two cases. If the object is placed at focus, sorry, at infinity. If the object is placed at infinity somewhere very far away, then the parallel lines will come, parallel rays will come. And since it is a diverging lens, so it will bend like this, that they will meet at focus. Okay, it will diverge like this. This is a diverging mirror. This will go, this will be goes like this. So if object placed at infinity, image will be formed at focus. Got it? Understood? So this is it always forms, always it like the convex mirror, this mirror, this is convex mirror, and this is concave lens. It is opposite. It like this mirror always form virtual image. Similarly, this concave mirror always form virtual and diminished image. Okay, you got it? Got it?
Yes, sir.
Let's suppose if the object instead of infinity, if it is placed somewhere anywhere between infinity and optical center, anywhere you are going to put that object. Okay. So what is going to happen here is, suppose you are going to put the object anywhere between optical center and infinity. Let's suppose you put the object here. Okay, then the image will pass. This is focus. Anywhere it is okay. So if you put anywhere, not necessarily you can put it here, you can put it here, wherever you like, you can put it. So this ray will diverge in such a way that it will make it. So this will diverge like this way, okay? That you extend this ray, this will touch the focus. You cannot diverge it like this anywhere. You cannot diverge it like this. And if you reduce it, it should meet at focus. It should meet at focus. The another ray should be passing through optical center. So here you see that when the ray is passing through optical center, it will not diverge, whether it is a concave lens or a convex lens. It will pass through it. Okay. So now where they intersect together, this is the image form. So image object. If object is placed anywhere between optical center and infinity, And when the image will be found, the image will be found between focus and optical center. It will always form between focus and optical center. Between focus and optical center. So they are the two cases. If the object is at infinity, the image will be found at focus. And if the object is placed anywhere except infinity, then the image will be found between optical center and focus. Here, in between. It is not going to form the image here, anyway, okay, or here. Okay, it will always form virtual image. So note it down. Done. Done, both of you. Abhi, done.
Yes.
Yes, sir, done.
So the rest and the